All right, we're here with
Okay,
a
she and me.
design review of RIP-7767. We got a special guest today, Vectorized. Vectorized, you want to take it away and just kind of walk us through what this is?
Okay. So this RIP rollout improvement proposal is largely inspired from the contract secured revenue system, which began on Canto and now is on some OP stack chains like Blast, Mode. I think Mode. Yeah, but the way they implement it is slightly different. Okay, so I will talk through why I'm thinking of this RIP. So the reason for contract secured revenue is that it allows developers to include fees in their contract that do not need any changes to any token standards because the gas fee is on top of every transaction. So instead of having changing the interface of a contract, you can just increase the gas fees and then capture a bit more value. But the way right now CSR works is that it is based on every bit of computation your contract use. So if I want to collect more fees, I will just write a loop that burns gas. I can use like keycut or spam EC recover or do some store, which is not exactly very scalable for the L2 because I will bloat the L2. So the idea is that instead of using these ON methods to burn gas, why not just have a special precompile that burns the gas in O1 time and O1 resource? And it will immediately return a portion of the gas burned as ether to the caller. So it kind of keeps the benefits while it removes the incentive to write bloated code. Okay, so this is the specification. Basically, this contract, what it does is that you pass in a U-in-256 value, how much gas you want to burn. And then this contract will burn the gas and returns a portion, not more than 100%, a portion, a fraction of the gas burn back as ether to the caller immediately. So it will do the direct way of sending an ether, which is via the state DB instead of using a call. Because some contracts they have some kind of callback which might not be constant in gas cost. So it has to directly send back the ether. Okay, there are two ways of implementing this pre-compile. One is by modifying OP gaf or the gaf level, the core level. And the other one for chains that don't want to touch their gaf, they can use the pre-install method. So this is kind of like the P256 rollout improvement proposal. So initially they came up with some kind of Solidity contract and then they code it in the gaf level. So some chains might prefer the pre-install, some chains might prefer the pre-compile. Okay, then these are the rationale, and this is the Solidity implementation. Okay, I won't go through the code line by line. So there are some comments. Okay, some people might not like this IP because like for example, if you're a shitcoin sniper, you buy and sell shitcoins with a bot very rapidly. This pre-compile can be used to implement sell tags such that when I buy and sell too fast, I will be forced to burn a lot of gas, which is converted back into ether. So for MVVers, it can be a not so good thing but I'm pretty sure they can get around it because they can analyze the simulation and detect, oh, I will call this precompile. I probably shouldn't do this sandwich. Okay, and the reason why I suggest that this is on the rollout is because on Ethereum, when you want to make any kind of changes, they are more conservative, not so experimental. But whereas on L2, we have seen like proven past records that this is a safe approach. Like Blast is not bloated today. Canto is not over bloated today. In fact, it's like quite a ghost chain. So it doesn't have that much of a worry that this will cause too much congestion. And also, if this precompile is somehow overused, you can tweak it such that when the base fee rise above a certain level, yeah, I record some. I did say something like here. Okay, so there is some kind of taper mechanism. So when the base fee goes above a certain amount, the amount of gas this precompile burn will be lesser, so that it won't bloat the base fee too high. Okay, and one last thing is, how does Blast and other L2s implement it today? So they don't actually modify the OP gas stack, the gas level, but instead they have a pre-install, which they deposit a shit ton of like about 1,000 ETH at the very beginning, and they run a cron job at the background to update how much each address can claim over time. So this is what the ideal claim over time. But because it's a cron job, they have some kind of lag time before they can claim the Ether back. If you implement it on the gas level, then there's no lag time. And I'm also not sure why Blast allows me to claim 100%, because they won't be actually earning any fees if I just wait the full 30 days to claim. So for this RIP, I suggest that instead of letting them claim 100%, make it a bit lower, like 90%, so that people will still be paying the sequencer money in order to use this precompile. Yep, that's all for my suggestions. Okay, so up for questions right now.
Yeah, I can go ahead. Like this is pretty cool, vectorized. Thank you for that presentation. When you say like, I understand the rationale behind not allowing this to be like 100%, let's say, Ether claiming for the gas consumed. But even if you do it at 100%, I think it should be okay, because you have some extra gas that it costs to do the external call, etc., right? So even though that should be more than fine, right? To just like mint or withdraw as much ether as gas burned. What do you think about that?
Yeah, I think okay. So when when I was planning this precompile, I was thinking like, what if I'm a competitor and I want to choke up the whole optimism, or I want to choke up base? I can I can immediately get the gas back, and then I call the precompile again. So I think that like 10% is a good room for error, so that in case of a bad actor, our chains won't be too congested. This can be tweaked over time. So okay, I don't know how is it made to be more configurable, because on the OP GAF, the ratios have to be kind of hard coded into the code. Yeah. Okay. Wait, I have to scroll down. So this is the yeah. So these kinds of there are some parameters, but they are on the compile time. Maybe it can be changed or refactored to runtime config. I'm not sure how.
Yeah, that'd be awesome. I think Mark and team are doing a lot of efforts to have more configurations be at the L1 level, right? And have those chains like kind of gather those settings from an easier way rather than having everything like on the client.
Yeah, I think design-wise, I think the challenge is that currently, I'm pretty sure all precompiles are just pure functions, which is why there's no like state access in the precompile and things like that. It's doable to add, but it's been something that client teams have tended to push back on a fair bit and tried to avoid making them have access to state. Makes me a little bit nervous about what conflicts we'll get in the future and problems we'll have if we do depend on it. But it's probably like it's not a showstopper, I don't think.
I see.
Yeah. Oh, sorry, Mark. Just one thing, which probably that's what you were going to say, but maybe the primitive of just translating gas to ether can be the precompile, but then we just have this be called by a specific pre-deploy that will have all of these configurations.
That's exactly what I was going to suggest. Just because, like what Adrian said about, none of the precompiles have access to the state or the EVM context. It's just a trade-off in, how big our diff to geth becomes versus, just enforcing from within the precompile that it can only be called from a specific address. And then that specific address, you're guaranteed that it will always pass in the EVM context because it'll just grab it from the EVM and then pass it in as call data. So I think that's like one trade-off space that we need to explore and like get consensus on. Because yeah, to Adrian's point, just like it's generally useful to like have the, more interesting precompiles, but it introduces a bigger diff. And, it's just a trade-off that we need to figure out how to make.
Yeah, one question on that is, if the primitive here is translating gas units to ether and only that, could we have a function on the, I don't remember the name, but the WETH contract that we have a shit ton of WETH on, and just have a function there that burns gas and returns the ether that it already has? I mean, is there a way around having to do a precompile?
That's true. That's a good point. Like as part of interop, we kind of have like this ETH liquidity contract that makes bridging really easy. I think the trade-off there is really around like this is a roll-up improvement proposal. So we'd still want some sort of interface that can be generic and possibly implemented on any chain, but then have its back end be, this ETH liquidity, contracts. And then just the other thing that we need to be mindful of is if we would just need to make sure that ETH doesn't get created out of thin air. Is that possible?
Okay. Right now, if you are to code it completely in Go, you have to be very careful. For example, there is some kind of logic that so if you directly just use pure Go to do it, you have to transfer the ETH from the, let me see, there is a base fee recipient. Yes, you have to transfer the ETH temporarily from the base fee recipient, which is a smart contract. And then at the end of the block, the base fee recipient will get back the gas fees. So you have to be very careful on how you do the accounting. The base fee recipient has a 2 ETH threshold before Ethereum can be withdrawn. So it will have some ETH inside. If it doesn't have any ETH, then this precompile will just burn the gas, but the the ETH refund will be skipped.
Yeah, that's something to watch really carefully, that we don't try and reduce the fee recipient balance below zero. Ethereum doesn't support that. It definitely had some risks in that implementation. You want to be careful. Yeah, it's more invasive, but you could try and track the refunds you do out of the base fee, then you can check if you're never refunding more. I don't know. Have to dig into the details, but there's a lot of risk around that, because you are effectively needing to mint ETH. Transferring it, I guess, is better if you live with the assumption that the base fee recipient starts with more money than can be refunded by this, which isn't necessarily true. It doesn't necessarily have any money. It doesn't necessarily, like gas prices are not necessarily same.
That's a good point.
I have just to go kind of to another topic. Maybe if you guys want, we can revisit this conversation. But why I'm interested in this primitive is because there is a problem with interrupt, which is all of the events and messages that I'm generating on a chain can be kind of executed and referenced on all the other chains, right? But the origin chain that actually made the computation required or provided the services or whatever to actually emit those events, which have some value, is not getting anything if those events are getting referenced, right? So if we could have a way for on the destination chain to have a precompile that actually says, oh, I will give you a little bit of gas money, right? Sequencer gas money, just either by burning gas, or even better, if we can just mint Ether by that gas and assign it to the origin chain to be either transferred atomically, which I don't think it makes sense, but eventually could be transferred out atomically, like through an interrupt message as well, or whatever, or withdrawn to L1 to the origin chain. This could be a great primitive for chains kind of being incentivized to like provide, I don't know, good service and kind of interoperability into other chains, and more specifically the Oracle chain that we're trying to develop, but which basically would be like, this would be very useful for it. But if not, I mean, this could always be done like through RPGF or whatever other method of like saying, oh, okay, this chain provided value, let's give it some of the sequencer fees or whatever.
But I guess the dumb question I have for that is, why do we need to pay that in gas rather than paying it in Ether? Like, if anything is calling a contract that calls this burn gas to pay Ether, it could just as easily say, hey, you've got to pay me Ether, and revert if it doesn't. And if I can get around that, I feel like I can get around the call to burn the gas and refund the money anyway. What am I missing?
Okay. So for example, if I want my ERC20 to accrue some value when people transfer, sadly the transfer from function is not payable. I can't like force Uniswap or Aerodrome to somehow change their contracts so that they can give me some ether if people buy and sell too fast. So this precompile uses the gas part of every transaction to capture to allow developers to capture value. So I don't need to call Uniswap to make changes to their contracts. I don't need to call anyone. I can just add this in my ERC20. Okay, I'm not sure how
Yeah.
other people will use it though.
I guess the kind of concern I have with that is it feels dishonest. Like I don't mean that in a critical way as such, but like when you require payment for something, having a payable method makes that really clear. When it's not payable, that's because people don't expect to pay, and then having it kind of pay them through extra gas feels like we're running around what should just be a contract change. And I appreciate that's a hard sell to get people to support that contract change, but that's because they don't want you to do this, and they don't want to use your changed contract.
Yeah, 100% agree. I think one of the main comments we had internally at Wonderland was like this can be abused. Like transactions do send more gas as a buffer to execute transactions, and this can be easily abused by always kind of like chewing at that buffer of extra gas, or messing around with transaction simulations to like steal more ether or more gas from users, like making a little bit of a weird UX. I agree that if this is like a payment service or a payment primitive, it should be like very, very clear if you're opting in or not, right? Such as, I don't know, the base fees or whatever. And if you don't really know if you're going to end up like paying more gas, or like the transaction is going to execute with more or less gas, yeah, it's a little bit trickier.
Okay, yeah, to that I will say that right now this, even without this precompile, on Blast is still, we can still do the same thing. We can just write a for loop to do a lot of S stores if we want to capture more value. So this precompile just makes what is possible now much more efficient.
When we're doing those S stores, you don't get the money.
Uh,
You're burning the gas. The sequencer winds up with the money.
yeah, but if they have the sequencer fee sharing, then I can get back the money eventually.
But that's a very limited set of people. Like it's doable, but I wouldn't be setting up a sequencer to pay people back gas, because gas is meant to subsidize the sequencer for the work it does and sell that block space. So when we add this precompile, you effectively open up everyone can do this same thing and actually get paid for it. So there's an incentive for it, versus anyone can burn gas and pay some third party who may or may not give it back to you, but probably won't, because you actually cost them money.
Mm.
Admittedly, Blast did set this up. So it's something that can be done, but I think Blast has done a lot of creative things as a way to differentiate, and I'm not sure they're necessarily all being fully tested there, because there's relatively limited use. It's still relatively new, and it's quite common in blockchain to have the normal state, everything works fine, but under an attack mode or in the worst case scenario, things break really badly. And it's actually that worst case scenario that worries me. Like I don't want to assume that people won't misuse this. You kind of have to assume that people will do the worst thing that they're in any way incentivized to do.
Okay, so there is a part of this precompile that allows this. Okay, so if the base fee is too over abused, you can reduce the amount of ether. So initially it's 90%, but if the base fee rise above 1 gray, which is pretty high, you can tune down the 90% to say 10%. And if the base fee rise even higher, anyone calling this precompile will essentially be burning away their ETH and get nothing back. So this precompile only gives back ETH if the base fee is low. So in times of a spam, this precompile will gradually turn off. You can add that as a safety mechanism.
Yeah, and I think you'd need that for DOS prevention, but I don't think it prevents users who are not expecting to pay. Like it's that kind of that sneaky backdoor to make a function payable still exists. I don't know how much we should be worried about it, but it does feel like another way that users get screwed unexpectedly. And typically we want to minimize that, and blockchain hasn't done a very good job of it in the past.
I think this can be solved on the wallet level. Like, for example, when you in every wallet today, MetaMask or so on, when you pay something, they will show you the gas fee. They will. So you will, wow, why it takes $50 to make this transaction? It will ring some alarm bells if they see like, wow, the gas fee is $50, although it's free. So it's not like it's showing zero. At least they will see like the gas fee actually costs $50 to transact on the L2, because this is the L2 gas. It's not like the part that is paid to the L1, which cannot be shown on MetaMask. So it's I would say it's quite transparent down here. It's just that it's not part of the not part of the smart contract.
Yeah, I mean that's true. I think it's less obvious than like literally I am telling it to transfer this much ETH. It can be fairly easy to kind of miss that the gas fees are high, particularly on an L2 where you get used to them being basically nothing, so you don't pay as much attention. And that's kind of why I think it's so valuable to have a separation of I'm paying this much to the network, like to buy that block space in gas, versus I'm paying this fee for using the contract, and being really clear. I don't know. I mean, that's kind of what I worry about. I'm not sure that there's necessarily an answer here. Like, it's not a technical thing. It's a philosophical concern, kind of more than anything. So I get that others might disagree. I don't know.
Okay. And let's say if chains want to implement CSR, this kind of thing, if we have a pre-compile, they can do the transaction simulation to it's easier for the simulator to determine how much of this gas is actually being paid to the precompile versus being like wasted on the keycard loop, because you don't know if in the traditional way, if I just use the loop, the simulator cannot somehow deduce that this loop is the part that is burning the gas. Whereas on the precompile, it's easy. Oh, I make a call to this special address. So anything that to this special address is immediately identifiable as amount of extra gas that is paid for payment purposes. So it's easier to like segment out the gas that is not meant for compute.
Yeah, I think that makes sense. Like if you adopt CSR and as a chain you buy into that, and so you're providing those gas refunds, this precompile absolutely makes sense. It's a much better implementation than literally burning the gas. The question really is, well, I don't know who we is, but do we want to support CSR?
Yeah.
There's a range of chains in the OP stack, so possibly this is an optional feature. Whether it's part of standard chains or not, I don't know. But I think that's kind of the key question.
I think it should be optional. It shouldn't be compulsory.
Yeah, that's true. But like whether it's part of standard chains is an interesting thing, and that probably makes a difference for interop and what users are expecting. Maybe not make or break that it has to be the same. Interesting kind of question around that. And then I guess the only thing that kind of flows out from that is if it's not part of standard chains in like the super chain sense, what's the the maintenance burden of it, which seems relatively low, I think. Particularly if we do like the pre-deploy wrapper around a precompile rather than making stateless precompiles or stateful precompiles. But that's kind of worth factoring in and considering as well in terms of what it costs to support as an option that some chains might use.
I think a wrapper feels better because like we don't want this to be turned on by default for all the chains. So yeah, if the chain doesn't have the install that calls the precompile, the permission precompile, then yeah, it will be off by default on the chain. I think yeah, that's a better approach.
Yeah.
Also more maintainable.
Cool. I think it's really interesting. I'm a bit nervous about it as we discussed. I got to drop and go to something else. But thank you so much for the time. I'm sorry to kind of run out halfway through this conversation. Like I'm not raising this as a over my dead body. I'm not trying to block it. I'm just
okay.
It's interesting to talk through those concerns. Yeah. Cheers. Thanks.
Oh yeah, I think if people launching casinos on base, it makes launching casinos on base much enticing. I don't know how aligned is that, but yeah.
I have a question. Like, let's say a new opcode gets released, and the opcode is literally burn gas, and you set that you send the amount of gas to burn, and it like instantly burns that amount. Would that plus a pre-deploy contract basically have everything that we need for this new feature for custom chains?
I think so. Like right now, if we have a pre-install, we can use the invading opcode to burn all the gas. But then we still need some way to top up the contract so that the contract has ETH to give back to the callers.
Yeah, we have that contract actually. Or we will have that contract, and that's something also Scroll has, I think, that they use this for deposits, which it's a nice workaround on having to mint Ether on every deposit or native token on every deposit of native tokens. So my question is, should we go the opcode way and try to add this as an opcode and make it kind of official? Or should we say like, fuck it, and if chains want to implement this, here's kind of the example implementation, take it away from here. Yeah, just use kind of the precompile with the wrapper.
Let's say if there is a one smart contract and then some people have to top up the smart contract, who will be the one that is topping up the smart contract?
Oh, on the case of the WETH, on the new WETH contract, the amount is going to be like almost infinite, if I'm not mistaken, right? It's like uint 248, so something like that.
Yes, that is the case.
Yeah, so it's pretty. It's not going to get depleted.
And you can etch any opcode, any bytecode onto that new WETH contract.
Sorry.
So
yeah, we can. It's part of an upgrade, but it has to go through governance.
Ooh, that's a nice approach. Is this WETH contract at a specific address or a standard address for all chains?
It will be in the future, yes. Once it's part of the interop spec. So when interop goes to production, that it will be.
I see. So you can somehow put this, you can change the bytecode of the web contract without changing the address. I think
It's a
that's a very good
1967
way.
proxy.
Oh, I see. 1967. I see. Okay, okay. Yeah, that sounds like a better approach. But how do you even give it infinite if? That's part of the core level, right?
It's part of the call level.
Okay, so someone has to fund the web contract.
No. Basically, we're taking inspiration from Scroll's bridge, where what Scroll does is they basically, in the Genesis block, they stick a ton of ether into this contract that can only be sent out if there's a deposit in L1 that's like backing the sent out ether.
I
So
see.
the approach is very similar for like being able to solve for sending ETH from an L2 to an L2, where basically we stick a bunch of ETH into this contract, and it doesn't count as like circulating supply ether, but it basically, if you burn ETH on one chain, then you're allowed to pull ETH out of this contract on another chain.
I see. Okay, it seems that this might be a better way to implement this. I'm not like fully sold that it has to be on the OP-GAF level. If it's on the smart contract level, I feel more comfortable actually. Yeah, because
I
the
think
risk is lower.
the
And
one
then you can
thing
turn
that
it
I would
off.
want to understand is if it's at the smart contract layer, how would we make it so that ETH is not minted? And this is specific to the logic of, and when I say minted, like created out of thin air, because we'd have to prevent the fees going to the sequencer ultimately. So we would
Oh,
need
yeah.
like debiting logic from the sequencer vault, and then you run into this issue where you can't underflow. If there's no fees in the sequencer vault, then you can't like debit ahead of time. So figuring out that solution, I think, is the tricky part.
Oh, yeah. Yeah, thanks. Yeah, good heads up. Maybe we still have to do a hybrid approach.
Yeah, ideally, it's as little changes to the client code as possible. Because that just adds like risk and it makes the diff bigger. And we always strive to try to keep the diff as close to L1 as possible, just for simplicity and management.
I see. Okay. I would think about more about that.
Totally. And if you have any thoughts, happy to jam on them in Discord. I think this is a cool idea, and I would definitely be supportive of this if we get it to a good spot where we feel really confident in its design.
Yep. Okay, I think I've nothing else. We are a bit more than an hour, I think. Is it? Oh,
I think we're at the 45-minute mark right now.
okay, 45 minutes. I see.
Um,
Okay.
cool. Yeah, if we don't have any other questions, I think that this is good to wrap up, and then we can get feedback from the wider community. So I'm going to stop the recording now.
Okay.
Thank you, everyone.